My name is Steve Parker. I'm the Director of Government Solutions and Sales for Cox Business. I want to welcome you to the Leveraging Technology Theater session, Software-Defined Networking. Let me get administrative a couple items out of the way. One would be your CompTIA credits. I'll make sure everybody understands that this is a 1-hour session. You have to stay 1 hour to get your credit. There'll be someone at the end of the session right out here who will scan your badge. This is good for one CompTIA A+, a Net Plus, continuing education credit, and one GIAC, continuing professional education credit. All right, again, scan badges out back, have to stay 1 hour, get your questions ready so we can make sure that we can meet that 1 hour. The second thing is there's a mic here in the middle of the floor. Please use the mic for questions. It's very difficult with all the background noise for people to hear you if you're just speaking from your seat. So don't hesitate. Just get up and walk to the mic and use the mic. Minimal uses of cell phone, please, and ringing would be appreciated very much. And without further ado, let me introduce David Stern, Electronic Engineer, Networking Evolution Branch of DISA. Thank you. Good morning.
Well, hello, everybody. Early on Friday morning. Thanks for being with me. So we're going to talk a little bit today about what this is doing with software-defined networking. But I need to make a couple abstractions real quick or kind of set the tone a little bit. So we're in the middle of an inflection between how we do business and how we have done business and how we envision business being done. So it's not just about the network. It's about the network, the compute, the storage, and how we secure all those. Traditionally, those are 4 separate domains that are managed very separately. And we're on the eve of an environment where we'll start to manage those together in order to provide capabilities for the warfighter. And it's very important to understand that this is way bigger than just the network. So you'll hear me talk in terms of network, compute, storage, and security, and that's the main thing. So when we talk about evolving, and I talk about a concept such as information core, from a customer perspective or warfighter perspective, the warfighter is really interested in how I get my information, how I store my information, how I process my information. Not so concerned about the details of the network, the compute, the storage, and the security. They need to make sure it's done, but from DISA's perspective, those are things that we can help the warfighter and we can help partner with them. So when we talk about an information core and some of the concepts that we'll lay down today, really we're talking about this information. This is all about what we do with information. So that will be the topic of the discussion today. I ask that if you have questions, you interrupt and use the microphone. And so I'd like to make this a really dynamic forum where we get your question asked while you're thinking about it, because if you're thinking about it, then the others will be thinking about it as well. So there's the disclaimer. You guys have been seeing this. This is their 3rd day now, so we'll move on. So we use the SDX moniker. X is supposed to mean it's a cool. You place your abbreviation code there. So you've heard software-defined data center. You've heard a lot of software-defined. So when you look at the X, it means a lot of different things to a lot of different organizations. We've trimmed the slide down a little bit. But for us and then where we're going, these are some of the high points. So we're very, very interested in automated provisioning and how we automate what we do today. And we'll show you some of the concepts that we explored last year and are moving into production currently. But this is automation by design. I talked about all those different domains. And with this, we're really talking about how do I singularly start to orchestrate or control these different domains together. And so that's where the power is starting to come from, is how do I take a task that takes 2 weeks or 2 months and then do that in 2 minutes. And that's the only way you can get that done is to collapse organizational boundaries, collapse TTPs and other techniques and procedures that are required in order to produce capabilities for the warfighter. So we also see improved end-to-end management and service delivery. We're moving into this Ethernet kind of world where Ethernet is a different protocol than TDM-based protocols, and there's different capabilities of that enabling transport mechanism. But there's not really good end-to-end management tools in that to find out where the issues are, and so that's part of what we see. Obviously, dynamic bandwidth reallocation, scheduling, and one of the big ones is less time in the box. So a good friend described this to me before I arrived about 5 years ago, and was like, there's all these boxes, and we connect boxes. And then when we think about doing maintenance and refresh, it's about the box. But it really isn't about the box. It's about the capabilities that you combine with these boxes. And we're at an inflection point now to where we're focusing on the capabilities and services, not circuits and not specific boxes or devices. So in terms of security and what we're talking about automation, that takes people out of the boxes. It takes the lower-level technicians out of the boxes. And so that's some of the thing about everything. It doesn't really matter where the devices are, what the boxes are, whether the network, compute, storage. If you're abstracting that and you're pushing away from that, then you're not in that. So programmability, obviously the little lower total cost of ownership, open standards, availability, and then in security. So I'll start laying down one major concept of software-defined everything or software-defined networks is that there's a separation occurring between what is the logic of a device and what the physical portions of the device are. We call that control plane and data plane. So the data plane is what's making a decision, a very brief decision about, hey, this piece of information is coming in here and it's going there. And I'm taking this piece of information, I'm going to copy it 4 times and send it to these locations. That's what occurs in the data plane. But in the control plane is where you're actually doing the higher order logic, which is saying, hey, I have these 5 switches, and I got to combine them, and I have to figure out how I'm going to push traffic or information through them, and how can I be more efficient in how I do that. And today I'll show you some graphics later, but the way we do that is we get a whole bunch of cooks in the kitchen, and those are all these devices, and they're talking to each other, trying to negotiate how this information is going to flow. And so the idea in SDN is really how do you separate that? How do you take the logic out of these devices and centrally look and say, okay, hey, I know where everything's running. I know it'll be better if I put a little bit more parsley in this instead of 5 people deciding on all the different ingredients that they want to add to that pot. And we know that if there's too many people that are in the kitchen and then putting ingredients in something that we're going to eat, that it doesn't always taste how we would all like it to. So that's software-defined everything. So I want to lay down one other concept. And the other concept I want to lay down is what the definition of the DoDIN is today. So today the DoD Information Networks is a globally interconnected set of end-to-end information capabilities, and you guys can read the lab. So now we're talking about this information core, and we're talking about globally orchestrating these capabilities now. It's a big, big distinction. I'm not just connecting stuff together. I'm not connecting boxes together. I'm orchestrating capabilities globally rather than segmented. And so as we talk about this is where the goal is how do you globally orchestrate that? So how do I globally orchestrate the network to support the compute? And how do I globally secure that in both the compute and the network? And then how do I do that in concert with the storage as well? And so there's how do you come up one level and look at it holistically? And I will say that as we started to look at this, new technologies have started to arrive, new things that we didn't think that we would be doing. We have some patents that are going through the process now. Can't really disclose them because they haven't been filed yet. But the patent and the subject matter of the patents really involves how do we solve problems? How do we solve reliability problems? How do we use the network in ways that we didn't think we could use the network before? Ways that we could use the network that we didn't anticipate before, because now we can see what's happening in the compute and do things in the compute at the same time we do it in the network and the storage and with security. When you look at it holistically and you orchestrate that from a central, globally type impression, there's just things that you can do that you can't do before, and that's an industry change that's occurring that we're going through now. So Automated provisioning is not software-defined networking. It is not software-defined everything. It is basically using software to provision our equipment in a non-manual fashion. The reason why we're really interested in this capability for DISA and the DoD is because it enables us to program and give customers the ability to influence or help us orchestrate the network compute and the storage. So while this automated provisioning is doing nothing more than configuring interfaces in an automated fashion, it's configuring interfaces on multiple devices in a very rapid fashion. So that means that instead of, like I mentioned before, 2 weeks or 2 months to actually put a circuit in action, if the capacity exists, then it could be as little as 2 minutes to provide a capability to the warfighter. So we did, we have done some work in the lab on automated provisioning. Obviously, the bottom lines are there. It's faster, it lowers costs, and expands our services. In terms of MPE and networks, I want to show you a couple other things here. So what we did is integrate into Storefront, or start to work how we would integrate into our Storefront, which is the customer portal for DISA. The provisioning goal for a certain service, and this one's going to be private LAN service, the provisioning goal is 7 days, and that's a goal. But the actual installation time for circuits, even when there's capacity available, is most of the time that's 30 plus days. What we demonstrated is we could give the customer the ability to provision some of these circuits, and then that you could provision that in 2 minutes. And the bottom line is we're moving from an environment where you're asking us, can you help me, to an environment where you can help yourself. And meaning that if the capacity is available and it's there, that you'd be able to provision it. So a lot in the industry are doing these type of these approaches already. So if anybody has hooked up to Comcast lately or Verizon lately or any of those carriers, we don't expect as consumers that we're going to wait 30 days to get internet at our house. Maybe if we're overseas. But in the United States, we're expecting that if I'm there, that I can call you, and if I'm lucky enough, I'll have some network interface equipment at my house already from a couple carriers, and then it should be as simple as me actually just making a phone call or getting on the internet. Even 10 years ago, we saw some of this. When you had a phone from Quest back then, you would plug in your line, and then somebody on the other end would pick up, and then what? You'd say, hey, I'm new here. I want a telephone service, and then in several minutes, you had telephone service. So in the DoD, we don't necessarily see that much differently, and we should not. We should allow customers the ability in private networks and mission partner environment, et cetera, to stand up these kind of connections. So let me walk you through this just briefly. So on the top right, that's an actual ordering interface, and you'll see it just says provision. It's something, it's a private circuit that's already in system. And the idea is you'll see some speeds, and then you'll see some statuses, and then you'll see, on the far right, you'll see a disco, a button where if you wanted to disconnect that circuit, then you could actually do a disconnect. And so here you also see some authoritative information below it. And the reason why we left that on there was that right there actually in the lab was every network for that service that was in the lab. And so those can get translated to friendly names, but if you're talking like here's a community of interest, and this is the medical community of interest, or this is this joint task force or coalition joint task force headquarters for this humanitarian operation, those can be networks that are segmented and in system. And so the point about labor hours is that automation in itself is being done or conceptualized and put into the lab and pushed into production really to enable agility, really to enable the customers to be able to cut down the provisioning time. But there's these second and third order effects in addition to that, which is how do you reduce cost and you reduce the expense. But that's not really the first order effect that we see for automated provisioning. The first order effect that we're looking for is to enable capabilities to the warfighter in an on-demand type environment. So we talk about tools, and one of the things that we have here is a map, and everybody's used to dots and lines, and then here's the status of the circuit that we have up now. But one of the things that we saw that is missing, and that we're seeking to correct is what is our capability and capacity now? What can I give you in a classified network that allows you to tell what I could provide to you today? What do I give to planners for them to understand that maybe I want to base my operation or I want to base my connections into DISA at location A, but maybe I don't want to do that at location A. Maybe I want to do that at location B or location C because I know that I have a green dot at location C and you can terminate my load. And you can terminate that into a load partly in Europe, partly in here in the DC area, and then partly at MacDill, but I have to wait 2 days for you to ship an interface to MacDill so we can insert that and start. Those are planning factors that we don't think necessarily like that today. We think that is it up or is it down, but not could it be up. And those are things that when the COCOMs visit us and ask for L&O input, those are cycles, and that takes time. So this is an effort to pull this information out of the network. And the one thing to say about this also is that in software-defined networking, this is all not manually entered. This is all derived out of the system live in real time and based on business rules and saying, hey, if we have an interface and it can be provisioned and it have enough capacity, then I can tell the customer that we can do that. And then the idea behind that is that, okay, so I know that I've got capacity there, then how do you act? And what do you act in that? And that is the provisioning pieces. So you'd be able to go to a website and then provision that capacity. So wouldn't it be nice for DISA to be in a position where, instead of our customers waiting for DISA was waiting for you? And so that's really the selling point for the agility piece here is that, automated provisioning in the systems can give DISA the capability to do that. I have a question.
Yes. Is this on?
Can you turn the mic on?
Thank you. On the what, where knowledge, getting that information to the war fighters, is that a vision or is that something you guys have today or something you're currently working on in the near term?
So what the capabilities you're seeing here are capabilities are moving to production currently. So they're going into the field trial and then the instantiation cases. So the ideas behind that are to properly secure the information. Today we basically have an order system where you have a list of locations and then you give us your hope that you'll be able to get services at the location, and then there's a time frame associated with that. So here the idea is to put that at a higher classification level to give you some visibility tools to do that. So there's some cross-domain services and other things required in order to do that, but those are definitely on the track that we're on as we move into field trial. So the last part of that in terms of the planners and operations, well, one thing we didn't talk about is internal operations. And we talked about how planners would get that, but then we have our own personnel, too, that are managing these services. And so this is very oversimplified, but if I know I've got 2 red dots, then that's actionable for, service managers to say, what is it going to take for me to get additional capacity at a site? I may have the capability, but how do I have the demonstrated capacity that I can have somebody provision against right now? And so that also, those are actionable tools. How do I take yellow dots, which require me to ship something there in a couple days, to how do I make that a green dot so I can terminate now? And that's the actionable part of these kind of concepts in software. Like I said, this is all near real time, so depending on how long it takes me to pull those devices to get this information, moving into SDN, which would be real time, and polling could take, every 6 hours or 12 hours. But then at that point, that's the information you have. It's not stale. It's not days old. It's not months old. You make a change, and within 6 hours, you're going to see that red dot end up being a yellow or a green dot. So that's kind of the idea there. Let's move on. So let's talk more about this information core capability. Software defined. This is more on the implementation side. So when we're talking about the information core, this is where we're starting to talk about the network compute and the storage and the security being integrated in one package. And the point about that is, if we start on the left side of this chart, you'll talk about, what we're really striving to do is to increase the ability for us to encrypt and provide services to customers to reduce the amount of time it takes to secure data. We have a mandate to harden and improve the security of our network and our infrastructure. Obviously, this enhances the command and control. And then we're really talking about how we introduce SDN into our enterprise. And the goals for that are to preserve our 100G DWDM deployment that's occurring now, and then to preserve the IPTPE or MPLS deployments that we have ongoing now. So besides those two fundamental architectural elements, all the other elements of the network are currently in play, and there's nothing that's sacred except for those two items currently. And so now we're talking about the command and control, of this information core, but I want to talk again real briefly about the circuit mentality. So we've been going 25 years, and our customers have been really used to talking in terms of circuits. My circuit is up and down. I have an A and a Z. And then we kind of went through part of this where we started, now I got multi-points. So now I have, from A to B to Z. And now I'm going to encrypt between A and B to Z, and it's been very complex and hard to troubleshoot. But that mentality is changing, because from a customer perspective, when we opened up, we talked in generality about customers don't care about, at the end of the day, they think they care about A to Z, but what they really care about is the information. How do I plug into an information core? How do I get that to process what I need? And how do I get the information I need where I need it? How do I share the information I need? How do I do that in segmented networks with mission partners or in humanitarian assistance, which is, I'm not necessarily prepared for that, because this is something that happened, and bad things in the world that happen, like tsunamis, they make very strange bedfellows. And so they have very strange requirements that we must meet. So, but that circuit mentality, that's kind of dead in this new concept, really moving into a service mentality. And how do we provide a service? So we talk about, in a circuit mentality, you would say, I need to be diverse. I need two paths to get from A to Z. But in the new methodology, diversity is just a service. So your service is diversity. And so I should be able to prove to you, or DISA should be able to prove to you as a customer, that your service is diverse. Likewise, enterprise email and those services, DISA should be able to prove that that DISA's meeting its SLA for that service. It's not about the connections that you have to NIPRNet. It's about the services that you have riding on NIPRNet. And so that's a fundamental change that is occurring. And then those are the high points. So this is focused. The way we're looking at implementing SDN in the DoD currently is to stand up what's called the new autonomous system. Autonomous system is an internet-based term, and that's basically one of the foundations of the internet, is that you have all these autonomous systems that are communicating with each other, and through that communication, that's how the internet runs. So in our core, we run pretty much the same way. We're built for extreme scale, and we have autonomous systems. So the idea behind the introduction of SDN in the core is to focus, obviously, on carrier-based Ethernet. The difference between Ethernet and carrier-based Ethernet is largely focused on reliability and service level agreement, and making sure that when you have a bit that it's one location and you expect it to get to another location, that it arrives. And that's something that we strive for in our networks today, but that was something that we could prove in this network. So we're focusing, obviously, on hardening, focusing on on-demand provisioning, focus, obviously, service level agreement, and mission partner flow, down to the service level. So one of the methods of implementation in software-defined networking and this information core that we're working on is, how do we agilely develop this? So how do we start? How do we get a couple provider edges that we're going to put into this network to begin with? And then how do we agilely develop these capabilities? But even more than that, how do we agilely develop these capabilities from a customer perspective? Not a operator or maintainer perspective, but from a customer perspective, where you have the need. I have the need for some compute. How do I order that compute? I have a need for some connectivity between multiple locations. How do order that compute. So I already have a network in place. I have 4 endpoints. I need to add another endpoint. How do I add that endpoint, and how do I do that in minutes? Those are the perspective of a customer. I don't think I have enough bandwidth. Do I really have enough bandwidth? What's been my utilization for the last 30 days? Can you show that to me? Those are all customer tools, and those are all things that are related to how is this doing? How can you have a conversation about a service if you have the service? How do you and you think that the service isn't performing well? So how do you have the conversation of where the problem is? How do you know? How do you know whether the SLA is being met or not? And then if it isn't being met, how do you know where that is? It's very complex. So we were talking about this autonomous system, and I think the core tenet of this is some of the leftover TDM we have. In the community now, there's a lot of people that are staying with TDM and circuit-based communications because they feel that DISA just can't prove that bit from one end is going to get to the other end. And so one of the core tenets of this information core design and the architecture we're putting forward is how do we prove the reliability of carrier-grade Ethernet, and what kind of tools can we provide? So that is, in essence, what we're talking about with an information core, and that's the bottom line. So this is a very busy chart, but I think it's important that you see what the big picture is. And the big picture is, on the left, you say the operational improvements. So we talked about increased availability, the reduction of deployment, and then proving SLA reliability. But taking you to the top of this chart, you'll really see that the primary goal is agility, to be able to provision circuits and capabilities and deliver those to the warfighter in minutes. Secondary and the third order effects you'll see are we should see reductions in our net operations costs. We will see some increases in development operations cost, but those should be a net minus. Now, taking you into the software-defined everything concept, you'll see there's boxes. We didn't put security in this one. It's implied. But if you have an information core and you have automated provisioning, which is our existing gear, we call that brownfield. Moving into software-defined everything, which is new and refreshed, more of a greenfield scenario. We kind of discussed some of the elements we would keep that are brownfield, and we discussed some of the new things that we'd be adding. You can read the chart, but I want to focus on the right side of what kind of we're working on. And we're going to show some things that are currently in the lab in a few slides, but there's some concepts that are occurring now. And we have a concept called every device is a sensor. And what that means is in this new paradigm, you have every switch in your network that you can turn into a sensor. So that sensor can give you operational information about how you're doing in terms of certain flows of information that you dynamically want to know about. So, for example, I like to use an example about video teleconferencing, that you're in a video teleconference and then you're doing fine, and then all of a sudden that video teleconferencing goes from fine to not so fine, and then you're on voice only. So in today's world, that's not something that we can actually do something about in real time. That's not something that you can hit a button or dynamically generate the network to go out and find out where that impairment is or to increase the priority of that communication. There are some solutions that are proprietary, but we're looking at more holistic solutions that we can get out of the network in general in all equipment in order to affect that kind of information. So you may not be initially able to fix that right away, but the point about that is why and where, and then that can affect change. And those are some of the pieces that are kind of missing today. Getting into continuity of government and some other real big kind of lofty topics. There's one thing, when you start to provision a network from globally, and you start to visualize the capabilities of a network globally, especially one as large as the current DODIN, then you have some of these other capabilities, which are, how do I take that part of our government and combine the visibility with other parts of our government, and how do I roll those up, and then talk about things like what the capabilities we have or what we could do. And that's not something that we have a large discussion of today. We have a discussion of circuits and what's in system now, But the idea behind SDN is that if you do have the visibility of what your network is today and what your current model is, you can combine that model with other departments or other parts of our government or other allies, and then you have the ability to do some very interesting things that we can't do today, like do large-scale simulations, start large-scale rehearsals in terms of network, and then you can use the same code sets, and those same code sets can be pushed into production, actually, and then you have a reasonable assurance that that's going to work how you expect it to. So you talk about agency-level COOP, and COOP's always, we think of it small scale. We're going to say this data center is going to COOP over to this site, but we don't really talk about COOPs in terms of, government and agencies and those kind of things. And we definitely don't talk about rehearsing, those kind of things. So in the SDN world, you could actually take your existing configurations, test them, and then you have a reasonable assurance that when you have to do that in a real situation that you've at least rehearsed, and you should be able to do that and implement that. So the last part about this, I'll talk about government circuit provisioning. We're not saying we're going to do this, but the bottom line is I'm going to show you some things in a few minutes here that we're actively looking at doing things on demand with last mile and with commercial data center and cloud services, et cetera. And I'll paint some pictures in a moment, but we're talking about how do I get the DoD and the government connected to a hotel, for example, or a convention center like this. How would I do that on demand in minutes? How would I connect that into the networks that we have today in minutes? And how would I secure that based on the service that is there? Sounds lofty, but it's within the realm of possibility now. Carriers are doing this. So working with those carriers is some of the things that we're working on now, and I'll discuss that in a minute for everybody. But at the end of the day, those are the things that are in realm of possibility, and those are the things that we're after. Those are some of the big picture items. So is everybody wondering what lasagna is about there? Come on, somebody's got to be. I mean, there's no lunch. I know y'all probably ate breakfast already, have some coffee. But the idea behind lasagna is really not to make you hungry, but we have a network today. It's really spaghetti, and there's no other way to say that. It's spaghetti, right? We have abstraction after abstraction after abstraction. We have things tunneling through different classifications, and it makes it very hard to troubleshoot or sustain any of that. So SDN, with different layers of classification, and private or other, it does give us the ability to start working on things that are more like lasagna, where you have nice layers, and you have nice layers between lasagna, nice gooey. Okay, I'm not going to make you hungry. But the idea behind that is that if you with this control that we're talking about of that you have control of those layers, and then you can start passing information from different layers up through the layers. So, in things like encryption and red and black separation, if you're taking the information and passing that up to a higher classification level, then you can get some visibility of some flows that we really don't have good visibility of today. And so we have another question.
Why don't we consider leveraging the power of SDN to take this to a black IP core?
Can you say that again?
Yeah, why don't we consider leveraging software-defined everything to take this paradigm to a black IP core as opposed to this layered model that you just laid out?
Well, I mean, I would say that this is probably along the same lines, except for without the complexity. So SDN really removes a lot of the need for port and protocol solutions. So today, when we want to change the way we do something, when you have these devices that communicate and negotiate with each other, a lot of times we're putting a lot of complexity and programming into multiple devices so they don't make a central decision, so that decision is distributed. So we keep layering more and more port and protocol solutions and increasing the complexity while we're doing it. That's the way we've done this for the last 15 years. So in today, with the Black Core, the way we segment is, with a port and protocol solution. In SDN, you may not actually have to have that port and protocol solution. Your controller would know the things that are flying through that pipe, and you would be able to prove the segmentation. And we're going to show you some tools in a minute that talk to that. But the idea behind that is that we're because we're taking the decentralization out for certain things and centralizing them, then you have a global view of where the bit is, who put it there, where it's going. And that's the thing we don't necessarily have today. And so if you know where it's going and what you need to do with it, then you're further along. And then I will say one other part about the security piece to that. Not only do you have to know that, but then you've got to be able to prove and validate and verify that. And that's something that's even hard in some of the big products that we're seeing, and NSA and others are evaluating, and vendors are here pushing, is that it's very tricky to actually do something in programming, but then to prove it another way, independent of that programming. And specifically, I'm talking about with APIs and having all your eggs in one basket and calling the API. But you don't call the API that's giving you the information and asking it if it's correct, right? You just don't do that. So now let's talk a little bit about this new global autonomous system. So we just finished something in the lab 2 weeks ago. It's pretty exciting for us. It's going to be underwhelming on this deck. The deck is kind of, I did this. Our graphics people didn't do it, so you can blame me. But the bottom line is what we did is we actually built this autonomous system in the lab. And what we did was we replaced, let me orient you real quick to this chart. Right here is one of our current backbones. And then we have what are called P routers, which are the core routing capability and switching capability in our networks. And then we have this, which is the ASBR, which is an autonomous system boundary router, and that's pretty much the gateway between different autonomous systems. So when I was talking about the internet's based on a whole bunch of autonomous systems, which are this, and then they communicate with each other through a protocol called BGP that allows big-scale networks to talk to each other and exchange information. So basically, when the bit's got to go somewhere on the internet to some web server out there, that's how you figure out where you got to go. So what we did, though, was first of all, we ripped out these proprietary switches and we put an OpenFlow-enabled SDN switch. The brand doesn't matter because I can put any commodity or vendor solution that supports OpenFlow. And then what we did was we put another one. And then we actually took a provider edge, which is the same as this. This is the hardware. These are the IPTPEs that we've deployed or are deploying, which is part of the MPLS project. But then we took a virtual one, put it over here, same code set, and then we said, okay, hey, can we get that to work? And we got that to work. And the point, though, was how do we preserve this multi-million dollar or, $500 million, a little less than $500 million investment in the IPTPEs that we're deploying now. So how do we not do a forklift? How do we preserve that? And oh, by the way, this doesn't really support OpenFlow as we see it today. So how do I take that provider edge and put it in an autonomous system that is all SDN controlled and will give us some of the capabilities we're talking about with SLA and diversity and proving and the tools to prove what we want. So we did it, and we got to work, and we proved that we could actually take this PE and run it into this autonomous system. So that did one thing for us, that proved in concept and in the lab that we could be successful. We may be successful. Not that we will be successful, but there's a chance that we'll be successful. So what we think now is that there's some investment that we'll be making in proving this concept out a little further with industry on working on some of the scaling and other methods to implement. And what you're seeing here is you're seeing like the first vestiges of how we would introduce SDN into the current day DOTA and how we would get to some of these information core concepts that we have today. So the real idea behind this is that if we drop an autonomous system like that we can agilely add provider edges or remove IPTPEs like this in here, and then that we can learn and we can develop these services and these customer-based tools that are required in order to be successful and to obviously increase the agility and decrease provisioning times. So we did one other thing that was really neat that I want to take another minute to mention is that not only did we use virtual routers instead of physical routers, but we actually started to take the control protocols and we started to take them off the network. And what that really means is, for example, BGP in a traditional network would come in this ASBR and then it'd go through the P, and then the PE. They would all be negotiated. That would be in what's called the data plane. And so now you've got control functions that are going through the data plane that you're trying to segment in a black core kind of concept, right? Where, I've got one class of data that I'm kind of putting a fence around, but really, in actuality, all the ones and zeros are still going through the same pipe, same way. And what we did was we intercepted those kind of control protocols at our edge, and then we pushed them into what is called the control plane. And the idea behind that is that at that point that it's completely segmented. And our control plane in this case was not routed back in band like we do things today. It was completely segmented. And so in essence what happened was we were actually trying to talk to this router, but we went into the control plane, and then we kept it in the control plane. So from the data plane, it looked like we teleported that packet from here to here, and the network never even saw that packet. And so the idea behind that is this was the first vestige in the DoD of actually taking packets out of the data plane and starting to do some of these concepts of hardening the control plane and taking control out of the data plane. We do it a lot today. Some of our systems are tunneled through the data plane. Some of our backbone systems are segmented. But the idea behind that is that I can't control, much like the internet, you can't control the other autonomous system, but you can add some effects into this new system that don't exist today. So I also want to talk about on-demand and last mile. So in an agile fashion, we were doing some development work before this conference, and we didn't make it, and that's okay. You don't always make everything if you're working agilely. In fact, sometimes you fail. And so we didn't quite make that. But I did want to show a service provider that we're working with. This chart, it got a little hiccup there. But the idea that we're working on now with this is how do we connect? We're currently connected to cloud, and we're connected directly through our equipment. We're co-locating equipment at a facility called Equinix that connects to some cloud vendors. But what I want to show you is what if we change that a little bit? And this is something that we're talking about and actually going to bring it in the lab and bring in a circuit into the lab. And what happens if we start to talk to this service provider? And what if we have a connection at this DMARC between our provider edge and a service provider network where not only could they maybe connect us to cloud services, but maybe they connect us to that last mile I was talking about, like this convention center. So what if I could take the address of this convention center and send that to that service provider and say, hey, do you have service at address X? And what if that would be through a call and a private connection between their server and our client and their server. And what if we made that call and they said, yes, I have it? Well, we have like 330 provider edges around the world. So what if I did this in seconds, and I did it at 3,000 service provider connections throughout the world? What if I had 10 at every PE, and I said, hey, do you have service to this address? Doesn't matter where the address is. It could be in Europe. It could be here in the United States. But let's use the example of this convention center. So do I have this address? And say they do. And say 10 come back and say they do. And they say, hey, the latency is this, and the cost is this, or maybe you've already pre-negotiated that cost. So in that case, then you could take that existing connection you have with your bandwidth requirements, and you could use that existing connection that you have to the service provider, and then that service provider could use that connection to connect you to whatever the distant end. And there's no difference between whether this is the cloud, last mile, and what type of cloud. The same kind of connectivity can be used internally for internal cloud. So things like MPE or things like our data centers and our abstractions. So once again, you're seeing another theme. This is all about how do we do stuff in minutes? How do we do stuff agile? And how do you build a security policy built into that based on what kind of service that you know you're getting out of that? And that's the concepts that we're working on now. So I think the last thing I want to show you is something we're calling Haywire. We really wanted to use Tripwire, but it was taken so many times we had to use something else. So the idea is how do you know in a network, especially one that's controlled with a controller, and you've taken decentralized control and started to centralize that, how do you know that you're meeting your policy? And how do you know that you're meeting your policy independently of that controller, which is the singular portion of how you're doing that? So this is a tool. Sorry about that. This is a tool. It looks fancy. But the bottom line and what we're working on now is how do we take our policy that we want to implement and how do we prove? How do we prove the segmentation without listening to whatever compute that's there, network that's there? How do you independently accomplish that feat? And so this is a technique, a patented technique from a vendor that they use what's called a graph. and then they graph all the actual network abstractions at all the layers to show what the connections are, whether you can make it to a distant end, whether you don't make it to the distant end, whether you're diverse and you have multiple paths, whether you're black holing traffic. You've seen things like that. This system, the reason why I'm showing it, this is actually a legacy implementation, but they originally designed this for SDN, and then they were too early. So then they went back into the legacy market and started scrubbing that. We've seen some things at AFRL and some things along this lines. But the point about this is, so when we start combining these networks between legacy gear and SDN gear, how do you validate? How do you have the assurance that your traffic in a black core is actually segregated and segmented? And then when it's not, how do you find out? And how long does it take for you to do that? So this is just a tool that shows how how you would see loops, how you would see different forms of traffic that would be from operational or a security context. But from an operational context, there's interesting things too. You've got MPLS connections. You've got your missing one. It's supposed to be both directions. Those are all manually configured. How do you make sure, or how do you validate that things are configured appropriately? So I know I've probably bored you all immensely, but we're at the end of this talk. Obviously, we're available to talk more about these concepts. So any questions before we call it a day?
Yes. How do you protect your software-defined everything network from single points of failure, such as an attack on, let's say, on your blade servers, your mainframes, and your storage arrays? Because when they take those out, you've got no virtualization, no instances. Number two would be, like, for instance, on the when you create a single...
Can we take the first one first?
Okay.
Yeah, because I'll get confused. So the biggest point is when we're talking about controller here, from a military standpoint, you have a controller, but you really have more of a distributed type of scenario where if anybody's familiar with the PACE concept, primary, alternate, contingency, emergency. So really the design of that follows that same kind of idea. So you'll have you'll have a controller that is as close to the loads as possible, and you'll have a primary and alternate, and then you'll have a tertiary controller that is somewhere else, meaning like at a more central location. And in industry, there's a big effort to work through this exact issue in the carrier space. So the idea is that your eggs truly aren't all in that one basket, that your storage is really shared or is in the storage area network that can survive some hits. Same thing with the control or the compute. And so it's not really a loaded question per se. Any application run by compute is susceptible to that. I can assure everyone here, I can't speak about it publicly, but there are some efforts at an emergency source as well. But that's outside the scope of what I can discuss in this environment.
Right. Number two is, I've heard it before, when you were saying that you can separate your control plane from your data plane. That's what they said about sandboxing, too. It didn't work.
So, I think that's fair. And what's occurring now is two things. So one thing in the hardware, there's physical changes. So if you look at commodity hardware, even proprietary hardware in the networking space today, there'll be an ASIC or an NPU, and then you'll have a CPU, and those are actually physically separated on board, and you have PCIe and some other things in between them. So in that context, there is actually separation between control plane and data plane, and then you can do some things in that CPU. You can add some hardening elements that we're talking about in terms of maybe I'm doing CDS in that, maybe I'm doing inspection, maybe I'm doing some other things in software actually at that layer, and that's all goodness. But there are some risks there moving forward because there's going to be a big element that wants to take that kind of infrastructure, including us, into software. and into strict software. And so then you've evaporated something that exists in hardware. You've done it for very good reasons, but that will have to be addressed moving forward if we leave hardware in certain locations in software.
And number 3 is, while it can take you milliseconds, maybe faster, to create a multiple instances, that means that the attacker, the aggressor, can create multiple instances from that one too. If he knows how to create that instance, and he will, he can attack your system thousands of times.
And you're absolutely right. Almost everything we're dealing with, everything I'm showing you is I'm showing you the defensive uses for these tools. There's a lot of them that are dual purpose that could be used offensively as well.
Hi. Question and a comment, if it's okay. Question is, in all of this, how do you protect the actual credentials, so the users themselves that are on the software-defined networks?
So in software and hardware, or both, or
kind of both.
The ideas? Okay.
Yeah.
Well, the idea really behind that is, you've all started hearing about trusted TPM or trusted platform module. So the ideas behind that, and I know you get into credentials, so bear with me as I go from the bottom up. But the idea is, how do you know that that device is actually a device you expect? So we didn't talk about trying to take these commodity devices and then provision them automatically, or take them from one known state and then to actually connect them to a controller and then actually drop the agent or the network operating system on that and spin it up, and then all the automation pieces of that. But the idea really is to start at the base and from a trusted source with TPM, and to validate that the code and everything moving up on top hasn't been modified and is what we expect. And I think that the approaches that we're going to take are going to be very similar in terms of that chain,
okay,
and then pushing that chain all the way as far forward. So that's the best I'm going to give you.
Sure.
Okay.
The other thing, comment-wise, he was on my straight man, the gentleman who asked the questions in front of me. I'm with CryptZone next door here, and we have a software-defined perimeter. So literally, we can take some of the things he was talking about from the attack surface and literally abstract it from the bad guys. And
Yep.
how do we best engage with you possibly after this?
Just after this?
Talk. Okay.
Yeah. Just
Great.
come talk to me. Yeah.
Thanks.
Thanks.
That's a great talk. The one question I have, I know you mentioned OpenFlow in your lab right now.
Yep.
Are you looking at some of the other emerging standards? I know there's so many, and have you done like a trade-off of, best, worst, or are you planning to do that at some time?
Well, so we started with one protocol. The difficulty in the DoD space is that some of the capabilities that we're looking at are really, we're looking at capabilities that can be deployed DoD-wide. So while a controller can communicate southbound with multiple protocols, OpenFlow, NetConf, even CLI or SSH, there's a variety of protocols. Some of the ideas in terms of what we can deploy in the entire DoD come from big thinking that has to start with the base. For example, a protocol like OpenFlow that you would say, okay, hey, I know I can get a capability today with this protocol. If that's a net-ready KPP and in the DoD, and every device must support that, then you may be able to get a minimum level of compliancy and a minimum level of capability with that kind of decision. So there's two things. You've got DIS's operations in the core that we're talking about and how we would control that. But at the same time, you've got bigger strategy, which is, if we're going to try to deploy a capability that we can do in concert with our mission partners, then we got to have common protocol to do that. The only problem with that today is that, I spoke about port and protocol solutions. Well, they tend to be very expensive, and it's very, very difficult to synchronize that along people with different boundaries or domains. So the best I'm going to be able to give you now is that, we're looking at OpenFlow. We're not excluding other things. We're not closed-minded that way, but we're looking for a general protocol that can give us some level of capability to do some of the hardening and the things that we want and some of the visibility we want. But that's not everything.
Yeah. Oh, great. Thank you.
That's it. Okay. Hopefully we're good on time. Okay. All right. Well, thank you very much.